Hey guys, we're in the science book today. When we were on science originally, before spring break, we were doing our ecosystem and habitats of Georgia um, unit, and now we're going to move from that to our heat unit. So we'll be in the science book for these lessons. So if you don't have a science book, I've gotten the page. This is the full page you'll need. I was able to get it full screen so that you could follow along on this page, and I'll move it as need be. And so when you have questions to answer, you can just pause this video and look at the pages. So you'll be on page 168, and we're going to start our heat unit. All right. We're going to be reading today pages 168, and we'll end on page 171. And at the end, you'll have 3 questions to answer in your science book. And again, if you don't have the science book, you can pause the video, look at the questions, and answer them on paper. So here we go. It's called Sharing the Warmth. Here are 2 common words, heat and temperature. You hear them every day, but what do they really mean? Scientists use the words very carefully. Some common words have special meanings in science. For example, when you use the word heat, you might mean how warm something is. In science, heat, notice how that is a word that is bold and it's highlighted, and that means we can go into the glossary and we can find this word. That's just one of our text features. It says, in science, heat is energy that moves from warmer objects to cooler objects. And when I went to a training, one thing that I was taught that I always thought was really cool is there are no cold items. Things are not cold, they're just without heat. And I was so amazed to hear that, to hear that something isn't really cold, it just lacks heat. I've never heard it that way. So let's continue to reading. This is a text feature. It is pointing to what's going on in this picture. Let's see what's going on. It says the temperature of the water in these hot springs is higher than the temperature of the monkeys. Heat flows from the warmer water to the monkeys. The monkeys then feel warmer. And just noticing, I see it looks like these monkeys have snow on them. So it seems like the environment around them is without heat, or we could say cold. And then when they got into the hot spring, the monkeys were cold, but the water moved on them and caused them to be warm. So heat was added to the monkeys. The heat from this water was added to the monkeys, which helped it stay warm. All right, let's keep going. Temperature. Notice another bold word here. That means we can find it in the glossary. Temperature is the measure of how hot or cold something is. Temperature can be measured in degrees. Water with a temperature of 32 degrees Celsius, which is 90 degrees Fahrenheit, is hotter than water with a temperature of 12 degrees Celsius, which is 54 degrees Fahrenheit. Fahrenheit and Celsius, these are ways that you can measure temperature. So here in the United States, if you see this F beside 90 degrees, the F means Fahrenheit. That's how we're measuring the temperature. We're using a Fahrenheit thermometer. In other countries, the United States is actually one of the only countries to use Fahrenheit. In other countries, they use a temperature that measures Celsius. So that's what that C stands for. Now 32 degrees Celsius is equivalent or equal to 90 degrees Fahrenheit. When you convert it, when you try to figure out how those measurements add up, 32 Celsius is 90 degrees Fahrenheit. Okay, so that's what those mean. And the little circle you see right beside the C, that is a symbol that means degrees. So you're measuring the degrees. That's how hot or cold it is. Remember, heat is energy. Heat always moves from an object with a higher temperature to one with a lower temperature. So again, in the case of the monkeys had a lower temperature the water had a higher temperature and the heat moved from something with the high temperature to the low. Okay, let's look at this. It says the red part of the metal horseshoe has a very high temperature. Heat moved from the fire into the red part of the horseshoe. So when I'm looking at this object, the fire is really hot and the heat moved to the horseshoe. So you could say that the temperature of this horseshoe is now, it's different than before it was in the fire. It's probably not as warm when it was not in the fire, and now it's warmer or maybe just as warm as the fire. And I notice this part looks really hot, but I bet if I compared it to this side right here, I bet this part is not as hot as this part. Okay, it says heat can move. In each picture, heat will flow from one object to another. Draw an arrow to show which way it will flow. So here we have the gas burner, and it looks like it's heating up water. So which way is the heat traveling? From here, we have someone roasting marshmallows. So you'll draw an arrow. Is the marshmallow giving off the heat, or is this fire giving off the heat? And with the water, this one's interesting. You have ice cubes and you have the water. Which one would be giving off the heat, the ice cubes or the water? All right, on to the next page. It's our last page for today. It says, turn up the heat. Heat moves from something warmer to something cooler. You rely on that every day. So let's see how we rely on heat. Would you like to eat nothing but raw food? Ugh. For things to cook, they must gain heat energy. Heat moves from the blue flames to the pot. Then it moves from the pot to the stew. The heat cooks the stew. So again, it's not until you turn this on, the heat on, that without the heat, this pot, you can touch it, it's fine, it's not very warm. But as soon as you put it under something warm, the pan gets hotter, and then the ingredients and the food that you put in the pot gets warmer as well, and that's how you cook your food. I like a lot of my food warm. So things like cooking a burger or steak, or in this picture, cookies, they require heat. It says number 1, this oven is used to bake food. Heat moves from the oven to the air inside the oven. Then it moves from the hot air to the food. The heat from the oven baked these cookies. Some things slow the movement of heat. The woman in the picture is using oven mitts. The mitt slows the movement of heat so that she does not get burned. Now, if you've ever pulled something out of the oven, which I hope you didn't do without your parent around and with proper protection, you put that oven mitt on and it doesn't burn like it would if you just put your hand in the oven, because that would be very bad. But the oven mitt is taking on that heat instead of your hand, and it's being a protective barrier. So it's a good thing she has those gloves on, because like this picture said, it's slowing down the movement of the heat so it doesn't burn her hands. All right. So all I want you to do today, guys, is just answer these 3 questions. You'll use the information in this chart that says safe food cooking temperature. So you'll look at the different foods and what they have to be baked at to be considered safe. So if food doesn't reach, if our raw food, like our chicken and our beef, eggs, if these items are not cooked up to a certain temperature, you can actually get really, really sick. So that's why you sometimes want to check with a thermometer to make sure that your food's reached a certain temperature. Because if not, like for example, if you cooked your salmon and you put a thermometer in it and it was 130 degrees, that means it's not cooked all the way. You want it to be 145 degrees or hotter. And that's a good way that you can catch food poisoning. Just not fun. So this is a lot of people who work as chefs or in the food industry. They have to check your food and make sure that it reaches the right temperature so that you don't get sick. All right, guys, we'll do some more on heat tomorrow. You just have these 3 questions and watch the video I've posted below. Have a good day.